This video covers the ALEKS topic, identifying solutions to a linear inequality in two variables. So a linear inequality in two variables can be written of the form ax plus by is less than c, less than or equal to, greater than or equal to c, where a, b, c are real numbers and a and b are both not zero. So when I have a linear equation, a linear inequality, it's like a linear equation, except instead of an equal sign, we have an inequality symbol. So for example, here I have y is 3 halves x plus 3, so my slope is 3 halves. My y-intercept is 3. Here's the graph of this line. But if I had the inequality of y is less than or equal to 3 halves x plus 3, our solution set isn't just the point on the line because it's less than or equal to, but it's also every other point that makes this inequality a true statement. So we have to shade. So the solutions of linear inequalities in two variables are all ordered pairs. In fact, they're all the ordered pairs that satisfy the inequality. Just as a linear inequalities in one variable have more than one solution, so do linear inequalities in two variables. And each ordered pair is said to satisfy the inequality. So what I want us to do first is I want us to identify solutions for linear inequalities in two variables. So here I have a table, and for each ordered pair, I want us to determine if the ordered pair would be a solution. So first I have y is greater than 2. So this is just in one variable, right? Its graph would look like a horizontal line if we kind of wanted to sketch it out. I'm not saying we draw the whole thing, but we kind of like visualize it, right? Here would be my line in thick blue right here, right? So y is greater than 2 would mean all the points above that. Maybe I should have used like a highlighter. So here's my line in green, and I could highlight above it. So I want to determine if these points satisfy this inequality. So I have y is greater than 2. Is y greater than 2? Well, here I have -4. Is -4 greater than 2? Nope, that's false. So this is not a solution. Next, I have 3, 2. Well, is 2 greater than 2? No, this is also false because it's strictly greater than, so it's not a solution. Here, -2 is greater than 2. That's also false, not a solution. But then I do have that 7 is greater than 2, which is true. Hooray, this point would be a solution. Let's do another example. This time our equation will have two variables. So this is we're still working in two variable land, but this was a horizontal line, so it only has one variable. Here would be a line with either positive or negative slope. We could calculate it out, but we don't need to because we're just trying to determine if these points satisfy the inequality. So I'm going to do this by substitution. 2 times, here's my first ordered pair, -7. Oh, I messed that up, didn't I? Let's start over. 2 times -7 minus 9 times -4 is greater than 10. So 2 times -7 is a -14. -9 times 4 is a +36, which is greater than 10. I think we can already see that this is going to be greater than 10. I have that 22 is greater than 10. This is true. So yes, it is a solution. Let's change color for -4, 1. I have 2 times -4 minus 9 times 1 is greater than 10. That means -8 minus 9 is greater than 10. That's not going to be true, right? This is false. So this is not a solution. Next, I have -5 and 0, so I have 2 times -5 minus 9 times 0 is greater than 10. That gives me -10 is greater than 10. This is false, right? This is not a solution. And our last ordered pair, I'll switch to red, is 6, -2. So I've got 2 times 6 minus 9 times -2 is greater than 10. I get 12 plus 18 is greater than 10. So 30 is greater than 10. This is true. So yes, this is a solution. Our last examples for x is greater than or equal to 3. Remember that the graph of x, if we were thinking about the graph of x equals 3, right? This would be a vertical line with undefined slope. So here I want x is greater than or equal to 3, so we'd shade to the right. We're going to cover this in more detail in the next 3 videos, I promise, in the final 3 videos of this playlist. Oh my gosh. Well, at least for now. So let's go ahead and check these for x. So here is 4 greater than or equal to 3. Yes, so this is a solution. Is -3 greater than or equal to 3? No, not a solution. Is 6 greater than or equal to 3? Yes. Is 3 greater than or equal to 3? This is also a yes, right? Because it's 3 is greater than or equal to, and 3 equals 3. So yes, this is a solution.